Okay, great. Thanks for coming here. My name is Jonathan, and I'm joined today by Martin again. And today we'll present a two-part presentations about VMS clusters on the cloud and hybrid VMS clusters. Starting with the first one, which is VMS clusters residing only on cloud in OCI. And the agenda for this presentation is that first we'll introduce a little bit about what it is we intend to do. We will go over the system topology of how the instances are set up and how long networking is and stuff like that. And then we will showcase how to set up VMS clusters residing in a single OCI region, which is done by something called local VCM peering. Moving on, we will cover some clusters that go across different OCI regions, followed by some failure scenarios, how the clusters behave on the cloud and stuff like that. So let's get started. The objective is to show the process of setting up a VMS cluster on the cloud, and we will focus mainly on the OCI networking and tunneling aspects of it. We will not really show you how to set up an instance or KVM, so we're only focusing on the actual OCI networking and the clustering things. We hope to be able to share our learned lessons and roadblocks, and hopefully you guys will be able to try this out yourself.
Yeah, well, it's weird to talk to the microphone. Well, anyways, you might have joined our previous webinar where we talked about this thing, but if you haven't, we'll do a quick system topology recap for you. This is basically what we have in Oracle Cloud setup for our instance. The setup is basically we have a bare metal system, but we're not really interacting with that. We have a layer 0, which we have not a lot of knowledge about. And then inside that layer 0, we have another layer where we have our Oracle Cloud or Oracle Linux installed. We're able to connect to that through the Oracle Cloud web console. And inside there, we have our KVM setup. And inside there, we have our VMS node setup. You can notice that we have two VNICs. Those are our network parts. With the first one, we are connecting to the host itself. And with the second one, we're using MacLead to pass it through straight to our VMS node. So you don't need to connect to the host instance first. You can directly go into the VMS VM itself. We also have these VCNs set up. Those are two different VCNs. They are virtual cloud networks. We're not gonna go into much detail. It's just the default config that you get on Oracle Cloud. And we separated these two because we want to have a separation of the host instance and the VMS VM. Now, how we set up this cluster? We get the same system topology and we duplicate it. This is pretty much the exact same setup, not a lot of changes. And we could have, of course, done two guests inside one instance, but we decided to go with two separate instances as redundancy. If one of your instances goes down, the other one is still up. That's the entire point of clustering, right? To make this work, because they're on separate networks, we need to add a third component called a dynamic routing gateway, or DRG. This is basically a router in Oracle between different networks. It will handle all of the routing for us. After creating the DRG, you need to attach it to your VCNs. And you need to add special route rules to define that that specific network or subnet should communicate through the DRG. You should note that you have to have different CIDR blocks as they can't overlap when you have a DRG set up. That will cause some confusion in Oracle side. How to actually create this? Super simple, mostly just clicking the big buttons. You have to click on that big button, which I can't even see, but it says create. You have to navigate to the networking tab, customer connectivity, DRGs, and then create your DRG. You have to give it a nice name, nice descriptive, like I did in this case. And after that, you have to go to the VCN attachments tab and attach it to your VCN that you already created. You'll have to do this for each of your VCNs, as mentioned. Here, you just click on attach, add a nice name for it if you want to, and select which network you want to connect. After this, you have to define the route rules, as I mentioned. This is basically all the subnets that you want communicating. You have to define each of them. The target type has to be dynamic routing gateway, and that's pretty much it. Now, we're gonna move it up a notch. We're gonna create a stretched cluster. What is a stretched cluster? We're going from 2 nodes in one region to 2 nodes in one region, in our case Frankfurt, and 2 other nodes in another region, which is gonna be Chicago in this case. Why is that? Once again, redundancy. If there's an issue with Oracle Cloud, if an entire region goes down, we still have another region to keep us running. What is the setup of this? Duplicate. You're doing the exact same thing that you did already, except you have to introduce another component in there. Yeah, you can notice that those are the 2 regions that we're working with, Frankfurt and Chicago. And this new component that we're adding, it's a remote peering connection. There's nothing much to be said about that, I think. Now, to create an RPC, that's pretty much the same exact thing. You have to click the big buttons, which are labeled. So first you navigate to a DRG page. You have to click on remote peering connections and create an RPC, which I named very creatively RPC. After you create one of them, in this case, I'm creating the first one, which is on Frankfurt. You're gonna have to find your OCID, and it's really important that you pick the OCID and not the DRG OCID, as that's a completely different thing. You have to copy this one. After that, you have to go to your Chicago network, create a remote peering connection there, and then you'll have to click on establish connection. There, you have to put in the previously copied OCID and select the region that that RPC is in, and then establish connection. That's really just copy and paste, click, and you're done. The networking part is set up already.
Yeah, and now if we start looking at how to improve the cluster, because if you are familiar with setting up VMS clusters, you might not notice that there's some issues presented with this topology that we have, that we have only 2 regions, and if one region goes down and the other one isn't favored with those, the whole cluster will go down. We also have an even number of those, so you would have to manually configure a favored sites for it to operate. So first of all, we thought about adding a quorum disk in a 3rd region for more redundancy, but this was unfortunately not possible as block volumes in OCI cannot be shared across regions. So to remove this single point of failure, we instead add a 3rd region with a quorum node. And same thing again, this is just an instance in a 3rd region, London, is set up the same way, but this can also be very minimal with minimal resource usage because its sole purpose is to be a quorum node and just provide a host to this cluster. The difference in the networking or the OCI setup is that you have to create 2 more of the remote peering connections. So between all the regions where you want to have a connection, you need to create one of these remote peering connections between each DRG. And to just quickly go through how we configure the cluster in VMS, we have the expected vote 75. Each node contributes with 1 vote. We have configured doing cluster over IPCI communication, so there's no bare SCS communication for this. We're also using unicast addresses and not multicast for this setup. And if you look at this picture here, it is essentially the exact same thing that I just showed you. We had the 3 different OCI regions and the circles representing nodes. and the lines between them represent the remote pairing connections. And I will just use this to go through some failure scenarios. And if you're familiar with VMS cluster behavior, this will also be very familiar for you because it's gonna behave quite similar. So in the first case, if we bring down one of the RPCs between two of the regions, Frankfurt and London, what will happen? It will lead to London leaving the cluster. And as I just said, this is behaving exactly as you would expect the VMS cluster to do. It doesn't matter that it is on the cloud and that you have these connections. One RPC doesn't really affect the other ones. So yeah, in this case, the nodes in one region will crash, but the cluster will reform and stay up, and it will be Frankfurt and Chicago that stays in the cluster as those two regions contribute with more individual nodes than London does. And another failure scenario, what if the RPC between Frankfurt and Chicago instead goes down? That will lead to Chicago leaving the cluster. And why is that? Both sides of this cluster can have total connectivity by themselves. If it's Frankfurt and London, they can achieve total connectivity between each other. And Chicago and London can also, but there is latency in OCI between the regions. In this case, Frankfurt and London will be the favorable side to continue. But once again, it's still behaving as you would expect a regular VMS cluster to behave. And these are just some example pictures of how the behavior looks inside VMS when you bring down the RPCs. So this is what it looks like when the RPC is down between Frankfurt and Chicago. So this is the view from one of the Chicago nodes. They still have a connection between UK and the other Chicago node, since that RPC is still up, but they are still on the cluster. Another failure scenario here. Obviously, in this case, we break two RPC connections between the regions. Then Frankfurt does not have a pairing connection between the DRG to London and not to the DRG to Chicago. So very obviously, they will be the one left out of this cluster. Yeah, the previous cluster here was Frankfurt, Chicago. When that RPC goes down, cluster reforms and Chicago London creates the new one. And if you want to recreate these tests, you can just go to the OCI web console. You navigate to the dynamic routing gateways that Martin talked about, and you find the RPC you want to simulate breaking, and you have to terminate it. It's worth noting, if you want to try this out yourself, if you do this, you actually delete the remote connection. You would have to configure it from scratch again to be able to have the connection between regions again. And this is just one thing to showcase that the behavior on the cloud is very, very similar to the regular cluster behavior of OpenVMS. The nodes in the regions can go down. Which nodes are allowed to go down? It doesn't matter in which region the nodes reside in, as long as there are total connectivity between some nodes that meet quorum, the cluster will stay up. And yeah, to recreate this, it's just as simple as crashing your node or shutting it down.
Now, before you do this, there may be some things to consider first. The first thing is the boot times. We noticed that the more nodes you add to this cluster, the longer the boot times become. So you might want to keep that in mind, that sometimes more is not better. This could be attributed to inter-region latency. On the Oracle website, you can actually see this table where they list all of their regions, and you can pick and match which regions you want to go with, and it will present to you the inter-region latency between those two regions. This is probably a good idea to look at when you're deciding which regions to go with. Also, this is a good thing. All of this that we showcased today, that doesn't have to be done manually. You can script all of it. Right now we have some scripts for this, so you can just be up and running in a couple of minutes. You just run the script, press enter, and all of this is set up for you automatically. So to summarize all of this, cross-region VMS clusters in Oracle Cloud can be done with BRGs. For example, that's one way. And this has quite a huge scalability potential as you can spin up this entire setup quite quickly and you can script all of this. But sometimes more is not better. Keep that in mind. And the cluster behavior on the cloud is pretty much the same as you would expect and as you're used to right now. So you will not get any surprises because you decided to move to the cloud. So this is part two, which is hybrid VMS clusters. By hybrid, we mean that you will have your on-premises nodes and some Oracle Cloud nodes connected together into a cluster. This is our part two agenda. We'll again just introduce the entire thing. The system topology, I'm not going into detail as it is quite close to the previous one. We'll go into the networking setup, how we achieve this, and we decided to use WireGuard for this to set up the tunneling between the nodes so they can have cluster communication and also keep it encrypted as well. Also, the DRGs are encrypted as well. So you don't have to worry about your cluster communication happening in the ClearNet. Yeah, we'll go into how we configure this entire thing, some challenges that we faced, and how you can avoid them in the future so you don't need to go through the same process as we did. So the system topology. So far, so good. Pretty much the exact same, except you can notice that we added another VNAME. This is because we are running one of the VNAMEs for the host instance. We are using the second one for our cluster communication with WireGuard, and we're using the third one exclusively for our VMS VM for any other communication. So we also keep the cluster communication and every other communication separate as well. And yeah, that's the bridge interface that we're using with WireGuard. Our topology will look quite similar. We had one region in Frankfurt, one region in Chicago, but they have a WireGuard tunnel in between them instead of the DRGs and the RPCs. So that's part one. We're done with it. This is a completely different approach. However, this is where instead of London, we're bringing in your own on-premises nodes that you already have, and they'll be communicating with that WireGuard tunnel instead of the DRGs. Now, since we're using WireGuards, we will not need DRGs and RPCs. However, we can pretty much only showcase one side and how we set this entire thing up, as your own network can be completely different than ours. Every network is completely different. We couldn't really account for all the combinations, but the two ways that you have is either setting up WireGuard on your host or setting up WireGuard on your network. So it's a network level WireGuard tunnel. We have to configure a bridge interface. This is on our cloud machine, our cloud instance. We're using the secondary VNAC, and this is going to be for WireGuard communication. Yes, you can see that we have the bridge set up. We ran into quite a few issues, which we had to figure out ourselves. As this is cloud, so there are some things happening under the hood, which we just don't know how it works. There are some workarounds that we had to figure out, and oh, too much. One of the things that we just didn't really know as there were no resources is that the primary VNAC that your instance is using, that's for your host, that always has to have a lower metric. Otherwise, OCI will get confused and it will not know which card to use for your communication, and you might not be able to connect to your host instance. However, after we've done this long process of figuring out what works and what doesn't, we managed to script this entire thing. So all of this can once again just be scripted, and you don't need to do this manually. Some of the challenges that we faced is, as I mentioned, the under the hood port forwarding. This was something that we didn't really know. But as there are multiple layers of virtualization on top of each other, the networking was kind of unknown to us. So in some cases, we had to call our friend WireGuard or Wireshark to capture the packets and figure out what's actually happening. Some firewall issues, as there's an Oracle Cloud network level firewall and also a firewall inside the instance as well. So we have to figure that one out as well. Then the different route rules that we have to set up. Jonathan will go into that one's a doozy. And also the different metrics that we have to set as well. Yeah, this is one of our squares that we used when we were experimenting with this entire thing. This was just a quick and dirty script to make our secondary VNet working. Now we actually figured out that we don't need all of this. We managed to find better ways, but this was very helpful when we constantly lost access to our machines and we had to get it back up and running.
Yeah, so if we move on to how we have configured WireGuard, so here are just some screenshots of how the WireGuard config file looks by itself. But essentially, it's a lot of route rules that in theory shouldn't be needed, but with all the OCI under the hood, networking and port forwarding, we had to really force WireGuard to use the correct VNIC and be connected to the right interface to forward the traffic as we needed it to do for our VMS guest. So yeah, make sure the correct VNIC is used, and that is also why we have these static routes to endpoints, and the endpoints in this sense are the other instances that we want to pair with and where the other VMS nodes reside that we want to connect with. If you do not define these static endpoints, OCI will just switch the network card that you are using, and you will very quickly lose where the traffic is going if you're looking at it in Wireshark. But you can find it again if you define these. And for the allowed IPs that you have to define this, you see there's for one pair, 3 different IPs, and that is 1, the IP address of the WireGuard interface of one of the pairs. 2 is the IP address of the bridge interface of one of the pairs. And the third one is the IP of the address inside VMS that is using the bridge interface. But all of this was needed for us to actually WireGuard use the correct interface, WireGuard being available inside the VMS guest, and all that stuff. But then with the bridge interface, we did not have access to the guest system from the outside. We could not SSH into our guest machine. We could not set up Apache web servers or anything. So that is why we have a Mac VTAP as well, which you have to configure. This is Windows Word Manager, which you can access from KVM. You configure it as a pass-through to the guest. And the one thing worth noting with this is inside of VMS, you have to disable the interface for addressing. Otherwise, it will spoof the MAC address, and OCI gets very confused about that and doesn't really like it. But the MAC VTAP is essentially the card that is used for all sort of network communication that is not cluster related. And having both the MAC VTAP and the bridge led to some confusion for us when we configured TCP/IP inside VMS. But essentially, we have to configure both the interfaces. And since there's no DHCP on the cards other than the primary card, we have to configure everything manually. So you have to set, at first, when you're in TCP/IP config, the default route to be the IP address of the bridge interface in the host. But then you will have to redefine all the default routes and define static routes to the peers, because otherwise the MAC VTAP didn't work when it had the default route of the bridge interface. And if you configured the default route to be the default route of the MAC VTAP, the cluster communication didn't work. So in one of the startup files, we redefine all the routes. And if you have a better idea on where to put this stuff, please let us know, because we are very interested in how to configure this in the best way. But this is just to showcase what we have to put there essentially. So you have to undefine the default route you already have. So the bottom one there, 10.0.2.74 is for the bridge interface, and then we redefine it to have the MacV one. And also here we show, you can see that after you do that in the startup, you can see that the default gateway is the one of the MacV interface. The static values you have to define are for the other peers, because otherwise there will be no cluster communication. Those WireGuard packets will not be able to come out of VMS. And the cluster configuration is very similar to the one where we had a cluster on only the cloud, but it's cluster over IP using IPCI communication. You have to use the bridge interface for all cluster communication, because MacV will not be able to use the WireGuard interface at all. And it is also configured with unicast addresses. And to summarize this, to have a cloud and an on-premise cluster is very possible. With hopefully you can use our learnings here and not have as much pain in setting up this as we had, because the networking on OCI is challenging but not impossible. You just have to realize when they're doing stuff you are not aware of. And as Martin mentioned before, your on-premise WireGuard setup will probably differ a lot to the one we have, because it's, yeah, every networking setup is different, so you will have to configure that yourself.
Oh yeah, and in real Apple fashion, we have one last thing. This is gonna be a bit brief. I can't really give you too many details. Just as we managed to actually cut out the middleman for Oracle Linux, and we managed to install OpenVMS natively on Oracle Cloud. This is quite cool. The issue before was that we were getting the wrong chipset. But if you select the VM standard E5 Flex, that will give you the correct chipset, and you'll be able to install VMS yourself natively. We have 3.5 ways of doing it. Uh, First, we have in Oracle Cloud a bucket. A bucket is where you would place your ISO file, your OpenVMS install kit. And then the custom image is basically your ISO plus some configuration. You kind of have to mess around with the configuration, as Oracle Cloud also has their own KVM in there, so we don't need to actually run KVM inside Oracle Linux inside KVM. We're removing the middleman, but by this way, we're also losing some of the customizability for our KVM host. So now we know the right combinations, but this is still very early news. The thing that has worked the best so far is the NetBoot, which is OpenVMS has this feature that you can download the entire ISO from a web server. We set this up ourselves, and that worked quite well. Another thing was we had our own scripted custom iPXE setup, but that's kind of the same thing. You're just getting the ISO image from somewhere else, some other server. And the other thing that worked really well is we already had a KVM instance set up for us, an OpenVMS install right there. And then we just took the QCAP storage file and uploaded that to OCI and booted from that pre-installed image. That one also worked quite well. And the half method that we figured out is we figured out a combination of custom options which allow you to actually boot from the install disk itself, but it took 3 days to load. However, after the 3 days, I decided to keep it running, then I installed it, and now it's up on the cloud and running just like how you would expect. I have no idea why it is, but yeah, after 3 days of patience, we managed to get it installed straight from the ISO. We'll get back to you when we figure out more, but this is quite recent. And yeah, this is our usual self-plug. You should get in contact with professional services, learn from our mistakes, so you avoid doing them. We're a good team, we're an awesome team. We have a bunch of people with a bunch of different skills and knowledge. So yeah, I'll say thank you for your attention, and any questions, please?
Have you any numbers on which bandwidth you're getting with stretch clusters from OCI? If you have to share disk between the cluster nodes on different locations?
Share disks.
Yeah, how much bandwidth do you get if you have to access disks from on the other side of something like that?
We haven't performed that testing yet.
And did you have some estimates or did you have some tests?
So and most of the tests we did was on the bandwidth of the network itself, but we have not done directly on the access to the other. That being said, the bandwidth of the network is order of magnitude. So bandwidth for network OCI, you get a medium, which is 3 or 5 gigabits per second, where you have only 2 or 4 choices. And the bandwidth of the network increases as per the number of CPUs that are there. You can also just pay a little bit higher than you have a higher network. But that being said, for the hard disk itself, it's a matter of sliding by the direct control on the promised number of IOs. I think it's random IO or it's max IOs. And you have also, together with that, as you slide about, you have control on the megabytes per second that you also have. And those are basically have 2 ways to fine tune. One way is just dragging the performance bar, and the other way is by actually increasing the size of this. So by generally doubling the size of this, you will generally also get double the performance until a certain threshold, a little about 1 or 2 terabytes, where then you're only allowed to increase performance. But between nodes, no, we have not tested the data transfer, but we understand it's most likely a hard disk communication rather than a network.
But you could have cluster with access in cluster node source across the cluster nodes.
Right.
So whatever you want to do there, you also need to have not only the latency problem, but also the bandwidth problem if you need to be on the other side of the world.
Right. Especially for transmitting the big file.
So the suggestion for that WireGuard thing, you consider using transit networks, such transit networks instead of WireGuard? It's to say instead of having 2 NICs almost dedicated, one WireGuard for IPCI and one for just normal transmitting, just that transit network with 2 sites together. It doesn't solve an encryption problem, but then you could add some encryption like there instead of using.
We didn't really look into that. We did look in a little bit to IP, and we did look in a little bit to IPsec because that is supported by OCI. So we wanted to do that as well, but in the end, we weren't really able to configure it on the Oracle side. So that's when we just started fully brainstorming on the WireGuard and everything. But so that is something we haven't tried yet.
However, that may all change when we get the next TCP/IP stack with IPsec. Yes. Anything else? Any suggestions?
Use cases.
All right. Well, thank you for listening to us, and feel free to approach us if you have anything, if anything comes to your mind. Thank you.
Thank you.